Hello everybody, we're now going to look at the graph of cosine theta. So we can graph this just like we graphed the sine theta ratio, and by considering what that triangle would look like if we superimposed it on the x and y plane. So let's imagine again another triangle, and we have our hypotenuse of 1, and that triangle is made up of the dotted line there, which is the opposite. But for cosine theta, well, we don't need the opposite. Cosine theta is the adjacent divided by the hypotenuse. So this time we're not really considering the y-axis. We're considering the other side of that triangle here, which is, of course, the x-axis. So if I think about that, that will be the adjacent if we consider this angle to be theta. So again, just like when we looked at the sine graph, let's think about theta being 0. Theta being 90. Let's bring the graph round to 180, followed by 270, all the way back to 360. And let's think about what the cosine is going to look like for each one of these values. So, first of all, imagine that angle is 0 and the line is flat against the x-axis. Well, if that was the case, let's draw that. We are looking just like this. We would have that adjacent. Well, if the adjacent is going to be really very similar to the x-axis here, in fact, not just similar, it will be exactly on the x-axis. So that adjacent is going to be 1. So our cosine theta will be 1 divided by 1. So at 0, cosine theta is 1. Now, as we move the angle greater and greater and greater, all the way towards 90 degrees, think about at every one of these different triangles, what's happening to the adjacent to that angle? Well, it's getting smaller. It's moving in that direction. In fact, it's moving, and so all the way towards 0. And when the angle of 90 degrees is reached, that adjacent, that x-axis coordinate point, is going to be 0. So we're going to have 0 divided by 1, which, of course, is 0. And now if we move past 90 degrees and we carry on, imagine theta being 100 or 110, 120, that adjacent looks here, it's here, isn't it, right? And as we move around, all right, okay, and that hypotenuse stays fixed at 1, we're going to get all the way to that adjacent being right here. And that will give us an adjacent of -1. So we're going to have our cosine theta ratio being -1 divided by 1, which is -1. Okay. Now, moving on even further than that, we can now imagine a situation where we are even further past 180 degrees. So imagine our theta has moved right round over to this third quadrant. Well, what's going to happen to that adjacent? Well, the adjacent again is this x-axis here. So as we move and we push, rotating right round towards 270, that adjacent, that x coordinate is going back again towards 0, all the way around until it is at 270, where it is at exactly 0. And then finishing off, as we now come round and we are making that theta all the way back past 270, getting closer and closer towards 360, that adjacent on the triangle again, well, that is getting larger this time. It's growing all the way around until we are flat back against that x-axis again, and we have our cosine theta equal to +1. So let's try and graph this now. Let's take these numbers and try to graph the function of cosine theta. So when theta was 0, we know that our cosine theta was 1. When we were 90 degrees, we had a cosine of 0. At 180, we're at -1. 270, we were back at 0 again. And at 360 degrees, we were back at our start point there at 1. So what does this look like? Well, if I was to draw all of the points, it will look something like this. And just like when we did the sine graph, it's going to repeat itself every 360. For example, an angle of 450 will be the same as an angle of 90. So we can carry on drawing this forever. And there is another cycle. Look there, that will complete the graph right up to 720. So your cosine graph looks something like this.